Have you ever noticed how the lengths of shadows change during the day? Watch how this stick's shadow changes as the sun moves across the sky. Early in the morning, the shadow is very long. As the sun rises, the shadow gets shorter and shorter, until at midday, when the sun is directly overhead, it disappears. During the afternoon, the shadow lengthens again, and in the evening the shadow is very long. The stick is vertical and the ground is flat, so the stick makes a right angle with the ground. At this particular time of day, the sun's rays make an angle of 30 degrees with the horizontal. Let's now experiment with the height of the stick. How does that affect the length of the shadow? Change the height of the stick by dragging it up and down. The sun's rays don't change. They still make an angle of 30 degrees. So the length of the shadow increases with the height of the stick. What do you notice about the ratio of the height of the stick to the length of its shadow? You should find that the ratio is constant no matter how long the stick is. In a right-angled triangle, this ratio of height to length is called the tangent ratio. We say that the tangent of 30 degrees is 0.577, and we write it as tan 30 equals 0.577. Let's see how we can use the tangent ratio. Little Teddy has a problem. He needs to find out the height of a great statue of Ramesses. Can you think how he might do this? He measures the distance along the ground from his position to the foot of the statue. It is 40.50 meters. And then he measures the angle that the line from his position to the top of the statue makes with the horizontal ground. It is 32 degrees. Since we have a right-angled triangle, we can use the tangent ratio to find the height h. Recall that the tangent ratio is the height over the length. So tan of 32 degrees equals h over 40.5. That means h equals 40.5 times tan of 32 degrees. In ancient times, they would have used tables of tan ratios to work this out. These days, we use a calculator. Tan of 32 degrees equals 0.625. So the height is 40.5 times 0.625. To the nearest centimetre, that's 25.31 metres. The statue is 25.31 metres tall. Here is one possible way the ancient Egyptians might have built the pyramids. The slaves pull the stones up a huge ramp. We already know that the ratio, vertical height over horizontal length, is called the tangent ratio. The ratio is equal to tan of the angle theta. But what about the distance the slaves travelled up the ramp? How can we find that? We can use some other trigonometric ratios. Sine of the angle theta is defined as the vertical height over the distance up the ramp. cosine of the angle theta is defined as the horizontal length over the distance up the ramp. The hypotenuse is the longer side of a triangle, so the ramp is the hypotenuse. The vertical side is opposite to the angle theta, so it is called the opposite side. The horizontal side is next to the angle theta, so it is called the adjacent side. Tan theta equals opposite over adjacent. Sin theta equals opposite over hypotenuse. And cos theta equals adjacent over hypotenuse.